Hi guys, welcome to the channel. In this video, we are going to cover what spin precision is, what is Larmor frequency, and how can we use it to obtain an NMR spectrum. I am your SSN. Once again, welcome you all to my channel. Without any further delay, let's go. What we all know about spins, we know there is either an upward spin or a downward spin. No, it is not like that. Spin is way more complicated than what we think. There are different distributions of spins. A spin may be distributed in any directions, and this distribution of spin we will call it as spin polarization. What happens if I apply a field and keep a magnet in that field? The magnet will fluctuate and point its north pole along the applied magnetic field. Likewise, I'm going to apply a field and keep a spin, a nuclear spin instead of a magnet. What happens? The spin will actually precise. This movement is known as precision. This is known as spin precision. By doing so, it develops a constant cone angle, and this cone angle is constant for every spins with respect to the applied magnetic field. This is my applied magnetic field. My upper spin and downward spin will show no movements along this magnetic field. In other words, it will not precise. But a spin which is perpendicular to the magnetic field will precess along its axis, and a spin which is tilted along the magnetic field will precess along its axis. Okay, so in what frequency these spins precess? That frequency in which this spins precess, we call it as Larmor frequency or omega naught. This omega naught is actually directly proportional to magnetic field. We can see it from these images. We are applying a magnetic field, so this spins presses along a constant cone angle with respect to this magnetic field. So this Larmor frequency is directly proportional to applied magnetic field. I'm going to remove this proportionality by introducing a proportionality constant. Here it is minus gamma b naught. This Larmor frequency is a sign dependent. It is very sensitive to signs. So if omega naught is minus gamma b naught, and if my gamma value is positive, my omega will be negative, right? Because omega naught is equal to minus gamma b naught. Gamma is positive, then my omega naught is negative. Then my spins will precess along clockwise direction. And if my gamma is negative, my spins will precess along anti-clockwise direction. How to remember this? To remember this, just imagine our right hand, right hand in which our fingers are closed. Okay, so here we can see that the fingers are closed along a clockwise path, right? Always compare your right hand with gamma's positive value or omega naught's negative value. If gamma is positive, look at your right hand, close your fingers, you can see, yeah, it is clockwise direction. So if gamma is positive, my spin will precess along the clockwise direction. Remember it. In terms of mathematical units, omega naught can also be represented as magnetic moment divided by angular momentum into the applied magnetic field. Unit of omega naught is radian per second inverse, because omega naught is nothing but the angular frequency. Just frequency, it will be second inverse. Angular frequency, it will be radian into second inverse. Why? Frequency is nothing but second inverse, but angular frequency has another parameter called angle. It is revolving around the circle, we may consider. So it has certain angle. A circle has, a full circle has 360-degree angle. We are representing it as radians, in radians. So we all know the value of mu in our previous video. In our second video, I have shown you what the value of mu is. So, and we also know the value of phi from our first video itself. So I'm going to substitute the mu and I values here. I previously told that omega naught is nothing but the frequency into the radians, that into the 360 degree. 360 degree we also call it as 2 pi, because pi is 180 degree. So We can also call it as 2 pi. So omega naught, I am rewriting it as 2 pi nu naught. Our radian, if we want to divide our radian, or if we want to neglect our radian, we must divide it by 2 pi, because radiant is nothing but 2 pi. We have to divide it by 2 pi. So if we divide it by 2 pi, we should divide it by 2 pi here also. So if we divide here also by 2 pi, we will get nu naught. This 2 pi will cancel. This I square root of I into I plus 1, this square root of I into I plus 1 will get cancelled. And we at last we get nu naught is equal to G beta n B naught by H. Yes, this is the energies level separation between two energy levels, which we have already seen in our second video. So Larmor frequency is nothing but the frequency in which the energy levels are get separated. So there are two energy levels. This energy level is separated by the frequency same to the Larmor frequency. So if I'm going to apply a RF pulse, that is a radio frequency pulse, I'm going to excite my molecules from lower energy to higher energy level. But the molecule will excite only when we apply a radio frequency wave with Larmor frequency. Okay, with the frequency equal to the Larmor frequency. So this phenomenon we call it as resonance phenomenon. We also know from the Boltzmann distribution law, 6.4 particles are greater in the lower energy level compared to the higher energy level. So by absorbing this, more amount of particles will go from lower to higher energy level, but only certain particle will come downwards. This equilibrium, we may call it as thermal equilibrium. So if this happens at a particular time, we will get a saturated point. Okay, call it a saturation point in which the lower energy level and the higher energy level both become equal. In this saturation point, the transition from lower energy to higher energy and the higher energy to lower energy is equal, and hence they are negligible. In other terms, we may call as no particles are excited from lower energy to higher energy or higher energy to lower energy. Then we may not see any signal in the NMR region, in the NMR spectrum. So what should we do? We have to make saturation point back to the thermal equilibrium, so that our particle will absorb some amount of radio frequency wave with normal frequency and go to the higher energy level, and some will come to the lower energy level. So with this we can absorb a spectrum. So what should we do? This we should reach thermal equilibrium by inducing the higher energy levels to emit some energy. So if we induce them to emit some energy, which they absorbed by the resonance phenomena, they will come back to the lower energy level and the thermal energy will be restored. We can observe this as a nuclear induction spectrum. We are inducing the particles to emit some energy. That's why this is called as nuclear induction spectrum. Later we now call it as nuclear magnetic resonance spectrum. This kind of induced emission, we can do it by two ways. The two ways we call it as relaxation process. What is relaxation process and how we obtain these NMR spectrums? Let us deal it with our later videos. So thank you for your patience. If you like this video, please give us your support by sharing this video, subscribing to our channel, click the bell icon, and please give me a thumbs